Yeah, and hi. Continuing a little bit about the glacier issue. So we are at global climate change, vital signs of the planet. NASA. Ask NASA Climate. Fire and ice. Why volcanic activity is not melting the polar ice sheets. Jet Propulsion Laboratory. Few natural phenomena are as impressive or awesome to behold as glaciers and volcanoes. I have seen both with my own eyes. I've marveled at the enormous power of flowing ice as I trekked across a glacier in Washington's Mount Rainier, an active but dormant volcano. I've marveled at the enormous power of flowing ice as I trekked across a glacier on Washington's Mount Rainier, an active but dormant volcano. Might be a hint, but let's continue. And I've hiked a rugged lava field on Hawaii's Big Island alone on a moonless night to witness the surreal majesty of a lava stream from Kilauea volcano spilling into the sea, its orange-red lava meeting the waves and billowing steam, while still more glowing ribbons of lava snaked down to the mountain slopes behind me. There are many places on Earth where fire meets ice. Volcanoes located in high latitude regions are frequently snow and ice covered. In recent years, some have speculated that volcanic activity could be playing a role in the present day loss of ice mass from Earth's polar ice sheets in Greenland and Antarctica. But does the science support that idea? In short, the answer is a definitive no. Though recent studies have shed important new light on the matter. For example, a 2017 NASA-led study by geophysicist Eric Ivins and Helene Serussi of NASA's Jet Propulsion Laboratory added evidence to bolster a long-standing hypothesis that a heat source called a mantle plume lies deep below Antarctica's Mary Bird Land, explaining some of the melting that creates lakes and rivers under the ice sheet. While the study may help explain why the ice sheet collapsed rapidly in earlier era of rapid climate change and why it's so unstable today, the researchers emphasize that the heat source isn't a new or increasing threat to the West Antarctic ice sheet, but rather has been going on over geologic timescales and therefore represents a background contribution to the melting of the ice sheet. I checked with Ivins and Sarusi to get a deeper understanding of this question, which our readers frequently asked about. Here is what I learned. Greenland has a long departed hotspot, but is now quiet. In 2002, the US-German Gravity Recovery and Climate Experiment GRACE and GRACE follow-on GRACE-FO satellite missions have recorded a rapid loss of ice mass from Greenland at a rate of approximately 281 gigatons per year. I just want to show or make it a really that you notice this. Okay, that's the time scale. 19, 2004, 15 years, which isn't that much in a bigger scale. There is plenty of evidence of volcanism in regions now covered by the Greenland ice sheet and the mountains around it. But this volcanic activity occurred in the distant past. Many of Greenland's mountains are eroded flood basalts, high volume lava eruptions that cover broad regions. Flood basalts are the biggest type of lava flows known on Earth. But volcanic activity isn't responsible for the current staggering loss of Greenland's ice sheet, says Ivins. There are no active volcanoes in Greenland. nor are there any known mapped dormant volcanoes under the Greenland ice sheet that were active during the Pliocene period of geological history that began more than 5.3 million years ago. Volcanoes are considered active if they've erupted within the past 50,000 years. In fact, he says that the history of the Greenland ice sheet is probably more connected to atmospheric and ocean heat than it is to heat from the solid Earth 10 million years ago. There was actually little ice present in Greenland. The whole age of ice sheet waxing and waning in the northern hemisphere didn't really get going until about 5 million years ago. While there are no active volcanoes in Greenland, scientists are confident a hotspot, an area where heat from Earth's mantle rises up to the surface as a thermal plume of buoyant rock, existed long ago beneath Greenland because they can see the residual heat in Earth's crust. Ivan says, while mantle plumes can drive some forms of volcanoes, Ivan says that they aren't a factor in the current melting of the ice sheet. Researchers hypothesize, however, that this residual heat may drive the flow of the Northeast Greenland ice stream, which penetrates hundreds of kilometers inland. An ice stream is a faster flowing current of ice within a larger and more stagnant ice sheet. Yeah, like a river. Recent modeling experiments show that if enough residual heat is present, it can initiate an ice stream. GPS measurements also provide evidence that the hotspot once existed beneath Greenland. That hotspot subsequently moved, however, and now lies beneath Iceland, home to about 130 volcanoes, of which roughly 30 are active. The hotspot is at least partially responsible for Iceland's high volcanic activity. Iceland also lies along the tectonically active mid-Atlantic ridge. Wait a second, let's go down because it's... Let's continue here. Multiple additional lines of evidence point to Antarctica's past and present volcanism. For example, topographic maps of the bedrock beneath the Arctic ice sheet give scientists clues to suspected volcanic locations. Analysis of volcanic rock samples reveal numerous volcanic eruptive events within the last 100,000 years, as to ash layers in ice cores. In their 2017 study of Mary Birdland, Cerruti and Ivans estimated the intensity of the heat production by the hypothesized mantle plume by studying the meltwater produced under the ice sheet and its motion by measuring changes in the elevation of the ice surface. That's actually pretty cool. You can watch how it looks beneath the ice or not. Yeah, it doesn't work when you zoom in. Anyway, let's continue. Now, an intriguing paper by Luce et al. Published in Nature Communications in 2018 provides additional evidence. The researchers measured the composition of isotopes of helium detected in glacial meltwater flowing from the Pine Island Glacier ice shelf. They found evidence of a source of volcanic heat upstream of the ice shelf. Located in the West Antarctic ice sheet, Pine Island Glacier is the fastest melting glacier in Antarctica, responsible for nearly a quarter of all Antarctic ice loss. By measuring the ratio between helium's two naturally occurring isotopes, scientists can tell whether the helium taps into Earth's hot mantle or is a product of crust that is relatively passive tectonically. The team found the helium originated in Earth's mantle, pointing to a volcanic heat source that may be triggering melting beneath the glacier and feeding the water network beneath it. However, The researchers concluded that the volcanic heat is not a significant contributor to the glacial melt observed in the ocean in front of Pine Island Glacier ice shelf. Rather, they attributed the bulk of the melting to the warm temperature of the deep water mass Pine Island Glacier flows into, which is melting the glacier from underneath. Now, there's hot water under the glacier, but Serosi notes that the changes happening now, especially in the West Antarctic, are along the coast, which suggests that the changes taking place in the ice sheet have nothing to do with volcanism, but are instead originating in the ocean. Ice streams reaching inland begin to flow and accelerate as ice along the coast disappears. Along the coast disappears. In addition, Serosi says the tectonic plate that Antarctica rests upon is one of the most immobile on Earth. It's surrounded by activity, but that activity also tends to keep it locked in position. There is no reason to believe it would change today to impact the melting of the Antarctic ice sheet. So, in conclusion, while Antarctica's known volcanism does cause melting, Ivins and Serosi agree that there is no connection between the loss of ice mass observed in Antarctica in recent decades and volcanic activity. The Antarctic ice sheet is at least 30 million years old, and volcanism there has been going on for millions of years. It's having no effect on the current melting of the ice sheet. So we are back at the beginning, almost. I have seen both with my own eyes. I've marveled at the enormous power of flowing ice as I trekked across a glacier on Washington's Mount Rainier, an active but dormant volcano. Maybe if they would think differently and glaciers are just volcanoes as they are different, like many volcanoes are slightly different than others, they would probably understand it better. But since volcanism and glaciers are obviously really not connected in any way, according to what is it, common theory, it might be really hard to figure out how they work after all. And there's many geysers in the world which are not hot. There's cold water coming out. And yeah, I leave it here. Probably I have to make some. Try to figure out how to make it this kind of video which would explain the whole thing a little bit better than just one article, and then somehow try to explain what I mean. And I should write a paper about that. Why it is so. Not just that it is so. The explanation why I think it's so that glaciers and volcanoes are basically the same thing. They're just a different kind of volcanism. And yeah, I leave it here. It's really interesting. Yeah, almost crazy. But somehow it doesn't let me rest. I somehow should try to get this other paper finished before I start a new one, but this theme is somehow so present. Stumble across it all the time, everywhere, in many forms. So yeah, it's amazing. But I leave it here. Thanks. Bye.